A spaceship is moving away from the Earth at a speed of 0.75 c when it fires a missile parallel to its line of motion. The missile moves with speed 0.55 c relative to the ship. What will be the speed of the missile as measured by the observer on Earth? Compare with the predictions of Galilean kinematics. So we draw the moving frame, which is the spaceship. X prime, Y prime, Z prime. We have drawn it in 3 dimensions. Here you find out that the T and Y coincide. X, Z, Y, T. So it fires a missile parallel to the line of motion of the spaceship. This is the spaceship. An observer is on Earth watching the spaceship. So it's moving in positive X prime direction. So in order to solve this problem now, we will use this formula. Ux for the observer on the ground, what he will see is this. V U x over c squared. This is what you will see. But I will, in exam, you just quote this thing and solve, putting it. But in case you don't know how this thing was obtained, let me show you how it was obtained from first principle. You know that the coordinate of this from here in inverse Lorentz transformation is written as x is equal to x prime plus vt prime, and the time is written as t is equal to t prime plus vx cx gamma outside here, where gamma is equal to 1 over square root of 1 minus v squared over c squared. You know this by now, you can consult your note. So if we differentiate this, let's say dx, we will have from here, we will have dx prime plus v is constant, with which the spaceship is moving, dt prime. Remember, this is prime. So we now have, for this, dt will give us dt prime here, v is constant, dx prime all over c squared, then gamma here. If we divide this side of the equation by dt, we will have ux. If we divide this side of the equation by dt prime, we will have dx over dt, which is ux prime plus v, because what we will have will be the x prime over dt prime plus v dt prime over dt prime. So we will have ux prime plus v. Also, if we divide here by dt, you will see that we will have 1. If we divide this side of the equation by dt prime, we will have dt prime over dt prime is 1 plus v over c squared. Then we have the x prime over dt prime, which is ux prime. So you now see that this equation over this equation will have ux over 1 is equal to ux prime plus v all over 1 plus v ux prime all over c squared. That's what we have and it's the same thing with this equation here that we set out to do. So from our problem, V is equal to 0.75 c, while ux prime is equal to 0.55 c. So that if we now plug it into these equations, we will have that ux is equal to 0.55 c for this one, plus 0.75 c for this one, all over 1 plus 0.55 c times 0.75 c over c squared. This c squared will cancel these two c's. So you see that we have equals to this plus this is 1.3 c all over. This times this will give us 1 plus 0.4125 from the calculator. So we have ux now to be equal to 1.3c over 1.4125, and that's approximately 0.92c. And you know that c is the speed of light, that's 3 times 10 raised to power 8. If you do that, it gives you approximately, or 2.76 times 10 raised to power 8 meters per second. So that is the answer. The people say we should compare the prediction of Galilean kinematics. In order to do that, you know that in Galilean transformation, this guy will see this thing as just x prime plus vt, because t and t prime are the same thing in Galilean transformation. In Newtonian physics, time is absolute, they are the same thing. So he will see x prime plus vt without this gamma. So let me write it down. You see what the observer on the ground will see. The observer on the ground in Galilean transformation kinematics will see x is equal to x prime plus vt, the inverse Galilean transformation. So if we, since t is equal to t prime in Galilean transformation, therefore dx over dt is equal to ux, and it's equal to the x prime over dt will now give us ux prime plus v. That's what you will see, because dt over dt is 1. So that if we slot the given, we will see that this one is 0.55c plus 0.75c, and that is equal to 1.3c. And you find out that this c is greater than the prescription given by Einsteinian postulate 2, that the velocity of light in all inertial reference frame are the same and is equal to c, irrespective of the motion of the observer or the motion of the emitting body. So that is how to do this. Kindly subscribe and like the video. Bye.